Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 5 to 8, which account for 22 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 5. Solve 2x add 5 equals 11 add 5x. So we've got an equation to solve and we're solving for that unknown variable, which is x. So what we'll notice is x appears on both sides of this equation. So my first step is going to be to eliminate the smallest x term. So I have positive 2x here. I know that it's a positive 2x because there's no negative sign in front of it. And I also have positive 5x here. I know that that's a positive 5x because there's a plus, there's an addition symbol in front of it. So I need to eliminate the smallest of those two terms. Well, 2 is smaller than 5. So I'm going to start by subtracting 2x because subtracting 2x is the opposite of adding 2x. So that means that it will eliminate the 2x for me. So when I subtract 2x from the left-hand side, that eliminates 2x, but I've still got this constant of 5. But then I need to subtract 2x from the right-hand side to balance the equation. I don't subtract it from the constant because there isn't an x in that term, so I can't combine them. But I do 5x subtract 2x, which leaves me with positive 3x. Now we have a two-step equation. So I'm trying to isolate the x term. So the next thing that I'm going to eliminate is the 11 on the right-hand side. Now I know that that's a positive 11, a plus 11, because there's no negative sign in front of it. So the inverse of adding 11 would be to subtract 11. So when I subtract 11 from the left-hand side, I'm doing 5 subtract 11. I'm going to do that on my calculator so that I don't miss out the fact that it's a negative solution. And then when I subtract 11 from the right-hand side, it cancels out the 11 and it leaves me with positive 3x. Now I've got a one-step equation. 3x is 3 multiplied by x. The inverse of multiplying by 3 would be to divide by 3. So when I divide by 3, 3x divided by 3 gives me x. So I've isolated x on its own. I have to do the same to the other side. So negative 6 divided by 3 is negative 2. Again, I'm using my calculator to make sure that I don't go wrong when I'm dealing with negative solutions. So x is equal to negative 2. Part B. Solve 8x subtract 3x add 1 in brackets equals 2. Give your answer as a fraction. So they've specified what form they want our answer to be in. So I'm going to rewrite this here. And the first thing I'm going to do is I'm going to expand this bracket. But what I need to recognise is that negative sign at the front of the brackets there, guys. There's no number with it, but that actually is an invisible 1. So this bracket is negative 1 multiplied by everything inside that bracket, okay? So I have my 8x that's not included in the bracket, but then I'm doing negative 1 multiplied by 3x. If you don't know what negative 1 multiplied by 3 is, pop it in your calculator. That gives me negative 3x. But then I do negative 1 multiplied by 1. Again, if you're not comfortable with your negatives, pop it in your calculator. That gives me negative 1. And this still is equal to 2 because I did nothing with the right-hand side. Our next step is to collect like terms. So we have 2 terms on the left-hand side that have an x. So we have 2 x terms. We have 8x and negative 3x. So 8x subtract 3x. So 8 subtract 3 is 5. So that leaves me with 5x, and I've got the subtract 1 because I did nothing with the negative 1. I was only dealing with my x terms. Now we've got a two-step equation. I'm aiming to solve for x, so I'm aiming to isolate the x term. So the next thing I'm going to eliminate is the negative 1. So the inverse of subtracting 1 is to add 1. So when I add 1 to the left-hand side, that cancels that out and leaves 5x. And then when I add 1 to the right hand side, 2 plus 1 is equal to 3. Now we've got a one-step equation. 5 multiplied by x is equal to 3. The inverse of multiplying by 5 is to divide by 5. 5x divided by 5 gives me x, so we've isolated the x term to solve. Have to do the same to the other side. 3 divided by 5, guys. 3 divided by 5, so I'm writing it as a fraction there. If you're not sure what that fraction is going to look like, put 3 divided by 5 in your calculator. It will show you. And we're leaving our answer like this because it asks for our answer to be a fraction. Part C. Tansy is trying to solve 1 is less than x add 2 is less than or equal to 5, where x is a whole number. Here's her working out. Ali says, you have made an error. Is Ali correct? Yes or no? Show clearly how you decide. Okay, so it is only a 1 mark question, but we're going to do some working out for this because we want to spot whether or not a mistake has been made in Tansy's working. So the easiest way to do that is to do the working out ourselves and compare. So we have 1 is less than x add 2 is less than or equal to 5. So like when we're solving equations, if we're solving inequalities, we're trying to isolate the unknown variable terms. We're trying to isolate that x. So at the moment it's got an add 2 with it. So we're going to have to do the inverse of adding 2, which is to subtract 2. And we have to do that from both sides. So when we subtract 2, the symbols are going to stay the same. That 2 eliminates from the middle there, but we have to subtract 2 from each of these values as well. So 1 subtract 2 here. Do it on your calculator so that you're careful with negatives. And then 5 subtract 2 here. So this is the range of solutions that x can take. Okay, so now we're going to write down what those solutions are. So we're going to include all numbers between -1 and 3, but we're not going to include -1 because there isn't a line underneath the symbol, so it's not included, it's not equal to. So we would start at 0, so x is 0, 1, 2, and we are going to include 3 because of that line, that equal to symbol there. So x is 0, 1, 2 and 3. Let's compare what we've done with what Tansy's done. So Tansy's subtracted 2, which is good. They've got that range of values that we got. And then they've listed their values, but they've listed -1. Well, -1 isn't an appropriate value. It shouldn't be included. So we've shown this, and then we're going to say -1 should not be included. Okay, part D. Represent the inequality x is greater than -2 on the number line below. Okay, so the first thing we do is we're going to put a circle above the number line at -2. So -2 is here, so we're going to pop a circle. That circle stays open, not coloured in, because it's greater than, not greater than or equal to. If we had that line underneath the symbol, then we would close that circle and colour it in. So now we're doing x is greater than -2. So all values on this side of the number line are greater than -2. They're getting bigger. So we're going to draw an arrow all the way to the end of the number line from that circle that we've drawn. Question 6. In an experiment, a scientist records the temperature y degrees Celsius of an object as it's heated for x seconds. The scientist thinks that the equation y equals mx plus c is a good fit for this data. The diagram shows his results on a scatter graph and his line of best fit. So we have a scatter graph and we have the scientist's line of best fit drawn there. Part A. Estimate the number of seconds for which the object has been heated when its temperature is 27 degrees Celsius. So we're going to use the scientist's line of best fit to estimate. So we need to go to 27 degrees Celsius on one of our axes. So this is our temperature axis here. So we're going to find 27. So 27 will be between 20 and 30. That's 10 places in total, and there are 10 small squares, so each small square is worth 1. So 25, 26, so 27 would be here. So we're going to take a ruler. I'm using a pen just so that you guys can see it nice and clearly. I'd recommend you use a pencil in case you want to rub anything out because you go wrong. So we're reading across from 27 to the line of best fit, and then where it meets the line of best fit, we're drawing a line straight down to the axes that gives us the time. And we're going to read off how many seconds. So it's between 10 and 20. There are 10 small squares, so each small square must be worth 1. It's worth checking because sometimes the scales are different, guys. So that's 10, 11, 12, 13, 14, 15, 16, 17. So we're estimating 17 seconds for this. Okay. Part B. When x equals 70 seconds, the scientist measures the value of y to be at 52 degrees. Use this information to decide whether the line of best fit is likely or unlikely to give reliable predictions for values of y when x is greater than 50 seconds. So we're going to say likely or unlikely, but we have to explain how we decide. So we can't just make a random guess here, guys, okay? So they've in real time measured that after 70 seconds the temperature was 52 degrees Celsius. Well, our graph doesn't go up to 70 seconds, so we can't read what it would be, but we could go up to 52 degrees Celsius. So what we're going to do is we're going to extend this line of best fit as best as we can. And then we're going to find 52 degrees Celsius from here. And we're going to read across and read down how many seconds. So 51, 52. So according to this line of best fit, 52 degrees Celsius is after 51 to 53 seconds, okay? When they measured it in reality, it was 70 seconds to get to 52 degrees Celsius. So because our line of best fit tells us something different, we can say that it's not likely. So it's unlikely to make reliable predictions. And I'm just going to state what I've said, that the line of best fit predicts 53 seconds for 52 degrees Celsius, okay? So the line of best fit there we go. Okay, part C. The line of best fit passes through the points 0, 15 and 10, 22. Find the equation of the line of best fit. Give your answer in the form y equals mx plus c. So remember, with y equals mx plus c, the m is your gradient of the line and the c is your y-intercept. Okay, so to find the gradient of the line, we need change in y divided by the change in x. You might have heard it as rise over run or other things, okay? And we're going to work it out from our coordinates. So remember, your coordinates go x, y in that order. So we're looking at the change in y. So if we're starting here at 15, we're getting to 22. So it's gone up by 7. So the change in y is positive 7. Now we need to look for the change in x. So x starting at 0, but then going up to 10, so it's gone up by 10, so the change in x is 10. So our gradient is 7 over 10, so we can write y equals 7 over 10x, but we need our y-intercept, guys. We can get that from our graph nice and easy. The y-intercept is where it cuts the y-axis, which is going to be at that point there, which is at positive 15, so we're going to put positive 15 as our plus c. Part D. Explain what the gradient of the line of best fit represents in this context. So the gradient is the rate of increase in the temperature, or in this case, how quickly the temperature increases with time. So I'm going to put that. It's how quickly the temperature, I can't write, increases with time. Question 7. So we have a diagram of a triangle, diagram not drawn to scale, so we can't measure anything directly from it. So the question says ABC is a right angle triangle. So ABC, we've got a right angle there. So I'm just going to make a note of that just in case I need to. I know a right angle is 90 degrees. Side AB is 4.8 centimetres. And angle BAC is 57 degrees. Calculate the area of the triangle ABC. So to find the area of a triangle, we need to do the base times the height, and then we're going to half it. So the base of the triangle is BC, so we will do BC times the height, which is 4.8 divided by 2. But to be able to do that, we need to know what BC is, okay? So we're going to calculate BC. Now this is a right angle triangle. We want to find this side. So we're dealing with two of the sides and we've got an interior angle that's not 90 degrees. So we're working with trigonometry for right angle triangles here, guys. So you're going to work with SOHCAHTOA. So we're going to start by labelling the sides of the triangle. So opposite the right angle is always the hypotenuse. Opposite the other angle is always the opposite, which means the other side must be the adjacent side next to that angle. Now we're going to identify which sides we're interested in. So we're looking for BC, and we know what AB is. So we're looking for the opposite, and we know what the adjacent is. We're not interested in AC, we're not looking for it, and we don't know what it is, so we're going to ignore it. We're going to use the opposite and the adjacent side. So when we're working with SOHCAHTOA, the opposite and the adjacent relate to the tangent. So you might have seen this kind of formula triangle before, guys. Okay, so tan of that angle is equal to the opposite divided by the adjacent. So I'm just going to substitute into here what I know. So the opposite is X, the side that we're looking for. And the adjacent is 4.8. Now, if you're comfortable with algebra, you can rearrange that equation to solve for x, because we're aiming to find out what x is, because that's the length that we're looking for. If you're not comfortable rearranging equations, you can use this formula triangle. So we are looking for the opposite side. X is the opposite side. So when I cover up the opposite, that tells me to do tan multiplied by the adjacent. So I'm doing tan of the angle multiplied by the adjacent side, which is 4.8, and I'm going to stick that into my calculator. So tan 57, close the bracket there, guys, whenever you're using sin, cos or tan, just in case. 4.8, so that's 7.391351,826, and that's in centimetres. But remember, this is the base of the triangle. Our ultimate aim is to get the area, so we're going to do the base times by the height and then divide by 2. So the area is equal to the base, which is still in my calculator, times by the height, which is 4.8. Press equals, and then I'm going to divide that by 2. So the area is equal to 17.73924438 centimetres squared. Now it doesn't ask me to round it in any way, but I'm not going to fit all of that there. So I'm just going to write 17.7 at 1 decimal place. Question 8. So we've got a diagram here. Diagram not drawn to scale, so we can't measure anything directly from it. A wedge is cut from a cylinder of cheese of radius 7 centimetres and height 5 centimetres. The volume of this wedge is 154 centimetres cubed. So this wedge here has a volume of 154 centimetres cubed. What percentage of the whole cheese is this wedge? Okay, so to figure out this as a percentage of the whole thing, we need to find the volume of the whole thing. So we're going to find the volume of the full wedge of cheese. So the volume of a cylinder is pi times the radius squared times the height. So you find the area of the circle, multiply it by the height. So we know that the radius is 7 centimetres, so that's 7 squared. And we know that the height is 5. So I'm going to stick all of that in my calculator, guys. So pi times 7 squared times 5. So that's 245 pi. I'm going to write it as 245 pi so I don't have to write a lot of decimals out. Okay, so the whole volume is 245 pi centimetres cubed. The wedge that is taken out has a volume of 154 centimetres cubed. So to figure out this value as a percentage of the whole value, we're going to write it as a fraction out of the total volume. So don't forget that pi. And then we're going to multiply it by 100. And that would convert our fraction into a percentage. So 154 over 245 pi times by 100. So that is 20.00804999, which is 20%.